Here we go with the review video. The first thing we did in this section was we looked at some of the economics of drilling wells. If you remember, this is the Excel exercise we worked through in class. I'm showing you the answers as we go through. What I'm expecting you to get from this is that you have an understanding of what tends to really drive up the cost of a well such that it affects the productivity. I'm sorry, not the productivity, but the profitability of the well. And what other factors really dig into the profitability of the well. So we started off with this is our base case. And then we said, what happens if instead of having 500 barrels, you have 400 barrels a day of initial production and then reduced it to 300? You could see going from 500 to 300 changes the well from being profitable. Remember that companies tend to look to use the 20% present value as the case they're looking for, which means that they would have an annualized return of 20% per year. So if you reduce the oil from 500 to 300, you move from a profitable well to an unprofitable well. What about with the decline rate? If we go from 30% to 40%, we cut in significantly into the profitability of the well. And remember, that is the annual decline rate, the amount production tails off each year. And if we go to 50% annual decline rate, the well becomes unprofitable. Now, what about changes in price? Well, we changed the price from 50 to 40. We saw that the well still made good money. Cut it to 35, okay. Cut it to 30, still making money. So in this sense, oil price matters a lot, but it didn't matter as much as if I pulled a lot of the oil out of the well. Then we looked at changes to the royalty, basically, to look at the net revenue interest. We went from 80 to 75, and you can see we still come up with a very positive number that's smaller than what we had before, but still very profitable. Even if we have to give up a 1/3 interest, the well is still profitable. So what this says is, yes, royalty, the amount of royalty that you have to give away matters, but not as much as the price of oil and the amount of oil that you get out. We looked at lease operating expenses. We found that we could be very wrong on these, and the economics of the well were still okay. Likewise, we could increase the price of drilling from 7.5 million to 10 million, still very profitable, and had to go all the way to 12.5 million to go unprofitable. So what you want to walk away from this is an understanding that really the amount that you recover is a huge determinant of the amount of money, whether your initial production isn't as high as you planned or your decline rate is steeper than you planned. Those sorts of things really get into the profitability of the well. The lease operating expense, the royalty, yes, it matters, but not as much as how much oil comes out of the well. And in some ways, how much oil comes out of the well matters even more than exactly what price you have to pay for it. The next thing we did in the class is we looked at a couple of AFEs. A common way to break up AFEs is to look at the dry hole cost, which is to say how much does it cost to drill the well and just find out whether there are minerals there. And the second is, what about completing the cost after I've drilled the well? Now, obviously, in the resource play, so to speak, where they're launching into the shale and they're highly confident that they're going to find well, this idea of dry hole versus completion isn't significant anymore, but it's still a good way to look at the cost. If you remember from the AFEs, and I encourage you to take them out and refamiliarize yourself with them, but the big thing I want you to remember is that when it comes to drilling the well, the dry hole cost, the rental of the drilling rig is the biggest expense. And interesting to me that what seems to be the second biggest expense is the cost of the casing. Sometimes those costs will include the cementing as well as the raw materials and the casing crews. But nonetheless, the second biggest expense is the casing. Then you have, for completion, you have the fracking. And this is one of the areas why vertical wells are less expensive than horizontal wells. Do they frack vertical wells? Sure they do. But how much are they fracking? A couple of 100 feet maybe? And so they can do that with 1 or 2 frac job or rounds of the frac. What about in the horizontal wells? Well, not only do you have all the drilling costs of drilling that long lateral, so you're potentially drilling a well that's twice as long, and therefore it's going to take twice as long. So you have those extra drilling costs, and also definitely with a horizontal well, you're going to have to pay for directional drilling, and all that goes with that. And sometimes that can be it can almost compete in the dry hole cost. The directional drillers could almost come in here at number 3 sometimes on the expense, or they do come in at number 3 on the expense. When it goes to complete the well, particularly a horizontal well, fracking is by far the greatest expense, particularly the long laterals where there might be 12 or 20 different sets of fracks. So that's a little bit on the finance. I'm going to change to some slides and go through those. Our next topic was the midstream industry. The thing I want you to realize is that transportation affects E&P companies because um, obviously the more their transportation costs, that squeezes the profits of the E&P companies. We talked about how the Permian Basin, one of the reasons the Permian Basin has continued to see a lot of activity in the downturn was they had very mature pipeline infrastructure and a relatively short distance to the refineries, so that they paid less transportation costs to get their product to market, and that was a big deal. I don't know what's happening to my little screen here. Let's get rid of it. Keep in mind that when it comes to transportation, virtually all natural gas is moved by pipeline. It's just too expensive to do it any other way, and that pipelines still do move the majority of the crude and the liquefied products. Nothing here. Rail, why did I expect you to remember why we saw the big spike in rail, but also the problems with rail? Simply said, rail isn't as cheap as pipelines, nor is it as safe. This was a horrible accident that occurred in Canada, and the irony of this is the particular rail cars that exploded were the new, supposedly safer rail cars because they were going to be harder to explode. Nothing on these slides that I want you to particularly remember. Pipeline basics, it's important that you remember these issues. Remember that the enemy of pipelines is corrosion, because the material is steel. It is, by law, it has to be buried at least 3 feet in the ground. They go from as little as 12 to 48 inches wide for the big gas pipelines. And you see an estimate of the cost obviously varies widely based on the terrain. Another challenge is between crude and natural gas is the variability in demand for natural gas is much higher than it is for crude. Even though we're going to see in the downstream industry that the amount processed by refineries varies a little bit, it doesn't vary nearly as much as gas consumption does. And because of that, you have to be able to store natural gas. So we have all of these storage sites that we talked about. And we also talked about line pack, where that's simply increasing the pressure in the line so that there's more volume of gas in the lines. I want you to be familiar with the advantages of midstream MLPs. And one of the reasons that the midstream is particularly suited is because it tends to be a steadier business than do E&P or upstream kinds of businesses. Then we talked about the LNG market. So it makes sense for countries to export LNG when they have surplus gas, and it makes sense for countries to import LNG when they don't have gas within their country. So you can see that 3 countries in Asia are the biggest importers of natural gas: Japan, South Korea, and China, and that's India. So these are the big natural gas markets because they don't have, in the case of these 2 countries, any domestic supplies. In the LNG business, well, that's not helpful. Hopefully we won't have any more of that. In the LNG business, the major cost is right here in the liquefaction process. This is the new site. Oh, wait, I'm sorry. No, that's not the new site of Cheniere. Because it is so expensive to build the liquefaction construction facilities, it's like building, obviously, a very long pipeline. They try to tie up contracts for lots of years to justify all this upfront capital expense. And again, you can see this is the deal that Cheniere was doing, is they were charging Henry Hub plus 15% plus the $2.15 per million BTU liquefaction fee. Well, remember the Henry Hub price for that's about $2.50 to $3 right now for gas. So it costs almost as much to liquefy it as it does to pay for the gas. And because of these heavy upfront investments, they try to secure long-term contracts. Okay, that's it for the midstream. On to the downstream industry. You can see that there are refineries all across the United States, but like it says on the slide, 44% of the capacity, total refining capacity in the United States is here on the Gulf Coast. You don't have to memorize those charts. Do want you to be somewhat familiar with this process, the refining process and the product slate. So remember that the first stop in the refining process are the distillation towers. And from that, you start to get the separation of the lighter materials. So this is where you would get off the naphtha, the LPG, and the gasoline, which you can get your first cut of that just from the atmospheric distillation. As you get into the heavier products, you do the atmospheric distillation, and then you start using these different products. Cracking is another one. You'll also hear the term reforming. We'll see that on another slide. And those things, for the most part, are trying to increase the volume of gasoline and, to a lesser extent, the middle distillates. I want you to be aware that all refineries are not created equal, and likewise, all crude is not created equal. So you've got this slide. I want to hold you responsible for this. Keep in mind of what the middle distillates are. Middle distillates tend to be the jet fuel, diesel kinds of fuels, and they are valuable, but the most valuable typically is gasoline. And I want you to be familiar with what types of crude are likely to yield the highest quantities of gasoline, and which types of crude are likely to yield the highest quantity of middle distillates. So again, this is a picture of the distillation tower, which is the first stop in the refinery process. I want you to be basically familiar with how this works. You can go back and rewatch the video, but remember they heat down here and then they use a lot of natural physics. And if you understand the physical properties, this becomes easier. And what this means is they heat it down here, and as it rises, it naturally cools. The heavier molecules condense sooner in the bubble caps and are removed. The lighter stuff goes to the top. So the very top would become the liquid petroleum gases, the gasoline, and then the middle distillates, and then the heavy stuff down here. And again, this is where the cracking kicks in, and you can see the cracking and the reforming used to make gasoline and some other items as well. I want you to be familiar with the cracking process. You can rewatch that little video, but the main thing I want you to keep in mind is cracking is one of those things that's used to generate higher value products out of a barrel of oil. Gasoline is the the easiest one, but also it could involve creating more middle distillates out of what would be the heavier types of byproducts. There are different types of cracking, but they all involve heat. And that makes sense given that what you're doing is you're breaking down the hydrocarbons into shorter chain molecules. So again, just be familiar with cracking and those things I talked about. This slide shows you that in 2014, refineries operated at about 90% capacity year-round, but notice that there is some seasonal variation. The variation is not nearly as significant as you see in the gas consumption. And again, it matches the different types of fuel consumption in the United States. No data from this is important, and I think that's it for downstream. On to the regulatory environment. This is primarily what I want you to walk away from. Know what is a state issue, know what is a federal issue. I'm just going to quickly flip through it. You don't need to know that the BLM is responsible. You don't need to remember these specific names of these agencies, nor these agencies. I want you to know that state laws are different. We talked about the fracking ban and then the different procedure for the pits between Texas and New Mexico. You don't need to specifically know the Texas issues. And then know that where the federal what tends to be federal issues are worker safety, and environmental issues, not asking you to regurgitate any parts of these specific environmental issues back to me. So again, main thing I want you to know is that state law generally guides E&P operations in terms of leasing, basic regulations and things like that, and federal law pertains to the big picture environmental and safety issues. That's all from that presentation. Oops, one thing I missed. We talked about the Safe Water Drinking Act, and we talked about the EPA study on fracking. I expect you to remember the overarching conclusion that was reached from the EPA study on fracking. Now on to the renewable industry. Whew, almost done. Let's talk about renewables. Start here. We talked about, and a couple of our presentations, class presentations, really drove this home. Likely coal is going to be the loser in terms of the power production because that's where the current renewables play, and this is the one that has the most greenhouse gas effects. Natural gas has about half the CO2 emissions, and so it would make sense that natural gas would grow. Then we looked at this issue of power density, and we said transportation is a tough market simply because they don't have the power density that allows the longer ranges, or they carry a very heavy weight penalty. I expect you to know what's baseload, intermediate, and peaking, and I also want you to be aware of when the load tends to peak, and then I want you to think about what types of energy better fit to meet that peaking demand and what types of energy better fit to meet the base load demand. So make sure you're familiar with those terms and be ready to apply them to different types of generation capacity and what would work best. Don't need to memorize this. I'm still weaning some of my final questions, so I'm going to cover probably a little bit more that's going to be on the exam. First of all, for the concentrated solar power, I expect you to know the pros and cons of CSP versus photovoltaic. Next thing is, I want you to understand this concept of net metering, and we had a long discussion about the importance of net metering in terms of distributed solar. So make sure you understand net metering. You have the 2 links you can turn to rewatch those videos if you need to. For wind, one of the potential questions would be who's the state with the most wind and why. So obviously that would be Texas, and we talked about why. Not only does Texas have very good wind resources, but it also has a grid that was built that transmits it from the windy parts of Texas, windy and more remote parts of Texas, to the more populated areas of Texas. Therefore, it matches market with capacity. We talked about this is a good rule of thumb that per megawatt, $1 million per megawatt hour, about 1.2 to 2.2. So if, for example, I were to say I want to build a 1.5 megawatt turbine, then I would take that 1.5, oops, doing that again. I'd take that 1.5 megawatt and multiply it by 1.2 and 2.2, and that would be the range I would expect. So I wouldn't expect a 1.5 to cost more than about 3.3 million, potentially as little as about 1.8 million. And then you want to have the idea of rated capacity. So you hear about a 2 megawatt generator. All power facilities and generation facilities have rated capacity. In the case of fossil fuels and nuclear power, that has to do with maintenance uptime and demand. Demand being the big one for the coal and the natural gas because they're demanded a lot less, particularly natural gas, than they're actually available. That's different with wind. Wind, this 33% is a rule of thumb about how much energy a given wind turbine will generate, and that's affected by obviously the quality of the wind. A place where the wind blows stronger, that rated capacity is going to be higher. Where it blows less, it's going to be lower. In a place like Texas that has really good wind, this 33% is a pretty good number. Again, I've not decided on all the final questions, but certainly this levelized cost of electricity issue, the thing I want you to walk away with is that with the subsidies, wind comes in fairly close, or actually, according to these things, cheaper than natural gas fired. In some of the presentations we had in class, they did a nice job of developing why these numbers may not be accurate. And then I also want you to remember that when we compare total subsidies in terms of the fossil fuels industry, if you add up all of the Treasury subsidies, so these are energy-related tax preferences, you get a number that's just under $4 billion. when you add up all of the renewables, the majority of which are wind, you can see you have basically 5 billion here, and then on this, another 2 billion for renewable energy. And the reason I didn't include some of these is you can see these are clearly not wind. I think you can say wind gets about $6 to $7 billion based off of the energy tax preferences, and that's something else important to keep in mind. And that's it for renewables. So if you know the stuff I've covered on this, you will be in very good shape. I'll tell you too that some of the discussions about the class discussions that we had off the papers, not discussions, but the presentations should really help you. For example, you would want to know why you would care if you're an E&P person whether the Dakota access issue gets quickly resolved or resolved at all, and those sorts of things. Let me take a look over here at some of the other questions just to be sure I've got everything covered. Yep, I think I've covered everything potential. Know all this stuff and you will rock it. I will see you Tuesday night at the exam.